Astronomers have located 6 galaxies that are currently trapped in a spider's web around a supermassive black hole. This discovery will help astronomers to better understand how supermassive black holes are formed, and also it will help them to understand how these black holes get to their enormous sizes. Astronomers found 6 galaxies that were currently lying around a supermassive black hole in a cosmic spider web of gas which extend to more than 300 times the size of our Milky Way galaxy. According to researchers, this cosmic spider web of galaxies was formed when the universe was less than 1 billion years old. And this is the first time that they are observing such a close grouping of galaxies. And they have assumed that they are seeing it very soon after the Big Bang. This discovery will help them to better understand how supermassive black holes, one of which exists at the center of our Milky Way galaxy, are formed and how they grow to their enormous sizes so quickly. The information that they have found also supports the theory that black holes can grow rapidly within large web-like structures, which contain a lot of gas to fuel them. An astronomer at the National Institute of Astrophysics in Italy has stated that this research was mainly driven by the desire to understand some of the most challenging astronomical objects, which includes supermassive black holes, and it's only supermassive black holes from the early days of the universe. He further went on to state that these are extreme systems, and to date we have had no good explanation for their existence. These observations were made by the European Southern Observatory Very Large Telescope, the ESO VLT. Astronomers also stated that the cosmic web filaments are like spiders' web threads. The galaxies stand and grow where the filaments cross, and streams of gas which are available to fuel both the galaxies and the central supermassive black hole flows along the filaments as well. Based on information coming out of the study, which was published recently, the light from this large web-like structure with its black hole of 1 billion solar masses has traveled to Earth from a time when the universe was only 900 million years old. In referencing the supermassive black holes, an astronomer has stated that our work has placed an important piece in the largely incomplete puzzle that is the formation and growth of such extreme yet relatively abundant objects so quickly after the Big Bang. It is thought that the first black holes, which are believed to have been formed from the collapse of the first stars, must have grown very quickly to reach masses of 1 billion suns within the first 900 million years of the life of the universe. Astronomers have had struggles in the past with explaining how sufficiently large amounts of black hole fuel could have been available to enable these objects to grow to such enormous sizes in such a short period of time. However, normally they would suggest that the newfound structure offers a likely explanation, and the web-like structure and the galaxies within it contain enough gas to provide the fuel that the central black hole would need to quickly become a supermassive giant black hole. Let us look at supermassive black holes. A supermassive black hole, which is normally called a SBH or a SMBH, is the largest type of black hole in the universe. These types of black holes have a mass of the order of millions to billions times that of the mass of our Sun. Black holes are a class of astronomical objects that have undergone gravitational collapse and would leave behind spheroidal regions of space from which nothing can escape. Not even light can escape from a black hole. Through evidence garnered through observation, this indicates that almost every large galaxy has a supermassive black hole at the galaxy's center. Our Milky Way also has a supermassive black hole in its galactic center, and this corresponds to the location of Sagittarius A. The accretion of interstellar gas onto supermassive black holes power active galactic nuclei and quasars. It should be clearly understood that supermassive black holes are generally defined as black holes with a mass above that of 1 million. Some astronomers have also begun labeling black holes of at least 10 billion as ultramassive black holes. Most of these are associated with exceptionally energetic quasars, and studies suggest that the maximum mass that a black hole can reach while being luminous accretors is that of the order of approximately 50 billion m. Supermassive black holes have physical properties that clearly differentiate them from that of lower mass classifications of black holes. First, you must consider the tidal forces that exist close to the event horizon, and the tidal forces are extremely weaker for supermassive black holes. The tidal force on a body at the event horizon is inversely proportional to the square of the mass. It should also be noted that, unlike stellar mass black holes, one would not experience any significant tidal force until very deep excursion into the black hole. It should also be mentioned that, since the volume of a spherical object, such as the event horizon of a non-rotating black hole, is directly proportional to that of the cube of the radius, the density of a black hole is therefore inversely proportional to the square of the mass, and thus higher mass black holes have lower average density. The radius of the event horizon of a supermassive black hole of more than 1 billion mass is comparable to the semi-major axis of the orbit of the planet Uranus. Like, comment, share, and subscribe. Leave your feedback down below and let me know what you think about this amazing astronomical discovery of 6 galaxies trapped in a spider web around a supermassive black hole that is quite similar to the black hole at the center of our Milky Way.